This video will cover Pre-Calc Notes 2.6. We're going to be talking about graphing rational functions. So let's first define a rational function. And a rational function is simply a polynomial divided by another polynomial. So we can see from the example that we're going to start off with, if I ask you to graph 2x over x minus 3, that would be an example of a rational function because you have in this case, a monomial divided by a binomial, which are both examples of polynomials divided by polynomials. And one of the key characteristics that we're going to notice when we do graph rational functions is that we're going to get these it's going to be a hyperbola in the fact that you have two branches, and you will also then, because you have the two branches, you'll have two asymptotes, and you're going to have either a vertical asymptote or a horizontal asymptote. Actually, you're going to have both vertical and horizontal asymptote. And the vertical asymptote is, if you can see by this diagram here, it's this line that I'm highlighting in green here, where the graph approaches but does not exist. And for this example, the horizontal asymptote happens to be the x-axis here. The graph is approaching it, but it does not cross it. It does not touch the horizontal or the vertical asymptotes. And for us to be able to graph these, we need to know what those horizontal and vertical asymptotes are, so we can make our branches approach those asymptotes, but again, never touching or crossing those asymptotes. So let's just take a look at one first by putting it in the graphing calculator. You can see that I've already done that over here. And as I look at the vertical asymptote is occurring here. You'll notice that it's going through at x equals 3. The horizontal asymptote is a little bit more difficult to see, but it's the line here. And that's occurring at y equals 2. So let's take a second to actually draw that on our graph. So if I draw my vertical asymptote at x equals 3 and my horizontal asymptote at y equals 2, we'll talk a second about how we actually got those numbers, and then we can make our branches. Notice that one of the branches is on this side, like so, and the other branch is up here, again approaching the asymptote but never touching or crossing the asymptote. And so that's what our graph is going to look like. And in our example, again, we can see that our vertical asymptote is crossing at the x-axis at 3, so it's the equation x equals 3. It's always, your vertical asymptote will always be the equation x equals some number wherever it touches the x-axis, because it's a vertical line. Your horizontal asymptote will be the equation y equals some number. In this case, it's touching at, or it's crossing at 2, so it's going to be y equals 2. And so this is what all of our graphs will look like. They will be the hyperbola that has a vertical horizontal asymptote, and then you'll have the two branches of the graph. Sometimes we'll get 3 branches depending on how complex of a problem we are trying to graph. But let's answer the question now, that how did we end up getting the asymptotes like this? Because the way that I got these when I graphed it was I just looked at the graphing calculator, but there's a reason why they are what they are. And that's what I want to talk about next in the next example here. So here are some rules for finding your horizontal and vertical asymptotes. The vertical asymptote is pretty easy to identify. You always will set your denominator equal to 0. So if we go back to our previous example, if our equation was this, y equals 2x over x minus 3, the way that we got our vertical asymptote was we set our denominator equal to 0. X minus 3 equals 0. We add 3, we end up with x being a positive 3. And you'll notice that that's what we had as the equation for our vertical asymptote. So you'll always do that to find your vertical asymptote. This would be the place where the graph doesn't exist, because if I put a 3 in here, I get 0, and I can't divide by 0, so that's why my graph is undefined there. Then the other thing that we want to do is come up with the horizontal asymptotes. And so this is where there are actually 3 different rules depending on the type of example that we have. We have to pick the rule that we need to follow. And basically what we're doing is we're comparing the degree of the numerator to the degree of the denominator. So looking at our example here, the numerator has an exponent or a degree of 1, and the denominator has an exponent or a degree of 1. So when the degree of the denominator is exactly the same as the degree of the numerator, like this example here, the horizontal asymptote is composed by taking the fraction that is formed by the leading coefficient of the numerator and the denominator, and then you're going to write it as y equals that number. So basically they're telling you to take the numerator leading coefficient, which is 2, the denominators, which leading coefficient is 1, and you write it as 2 over 1, which we can then just reduce down to 2. So that's why the horizontal asymptote was y equals 2. So depending on what the degree of our polynomial is in the numerator and in the denominator will depend on which of these 3 reasons we use. So we used this reasoning in the first example. Let's just go over the other 2 reasonings. The degree of the numerator is greater than the degree of the denominator. So let me give you an example of that. If I have maybe 2x squared over 3x to the third plus 1. The degree of the denominator in this case, which is 3, is greater than the degree of the numerator, which is 2. The horizontal asymptote will always be the x-axis, so therefore that's the equation y equals 0. So whenever it's the x-axis, it's always the equation y equals 0. Okay? And then finally the third one is when the degree of the denominator is less than the numerator. So an example of this would be maybe 5x to the third over x plus 2, because you'll notice the degree here is 3, the degree here is 1, so the numerator is greater than the denominator. It says the horizontal asymptote is a slant asymptote, and we'd end up having to do synthetic division to come up with that. And there will be an example of this in the notes, so I will get to that when we actually are trying to find the actual asymptote that way. So you'll see it done a little bit later in the notes. So when we try to graph these, the first thing that we want to do is answer the question, what is the horizontal asymptote, what is the vertical asymptote? So then we can then pick numbers to actually plot the 2 branches of our graph. So let's do that with another example. Okay, so here is our next example. The equation is 3 over x plus 2. That's what we want to graph. So let's find our horizontal and vertical asymptotes. So our vertical asymptote is when I set the denominator equal to 0. So we would find that it would be x equals negative 2. So let's get out a highlighter. And I'm going to use a highlighter instead of my pencil because it'll show up a lot better, and then I'll also realize that that's not really part of my graph. And let's draw a vertical asymptote at x equals 2. Okay, then to find our horizontal asymptote, we have to compare the degrees of the numerator and the denominator. So the degree of the numerator is actually degree 0, and the degree of the denominator is degree 1. So in this case, the denominator is greater than the numerator. And when that happens, if you're looking back at your front side of your notes, you'll notice that it says that the x-axis is the horizontal asymptote. So that's the equation y equals 0. When you do write your vertical and horizontal asymptotes, please make sure you're writing them as equations of lines. They'll be vertical or horizontal, so they either have to be x equals a number or y equals a number. So let's get out our highlighter and highlight then the equation y equals 0. And so now I can put my 2 branches of the graph on here. Now you can see from the graph, you'll notice that I already have it over here for the graph on the graphing calculator where the branches lie. But if I didn't have the graphing calculator to help me see where those branches are, I'd have to plot points. So I want to show you how to do that, because really what you need to do is pick numbers that are on either side of your vertical asymptote. So if this is negative 2, you want to pick numbers that are bigger than negative 2. So for example, negative 1, 0, 1, and 2. And that will give you one of your branches. And then you want to pick numbers that are less than negative 2. So negative 3, negative 4, negative 5, and negative 6. And that will give you your other branch. So if we go and start plugging in points or using the table function of the graphing calculator, you should be getting the following values when you plug these in. This would make 3, 1.5, 1, and 0.75. This would make negative 3, negative 1.5, negative 1, and negative 0.75. So let's take some time to actually plot those points. Negative 1, 3 would be way up here. 0, 1.5, 1, 1, 0.75. You'll notice I'm getting that first branch, and when I draw this, I want to make it a smooth curve that approaches the asymptotes but does not cross. My other branch should be down here, as I can see from the calculator. Let's just confirm by plotting these points. Negative 3, negative 3, negative 4, negative 1.5, negative 5, negative 1, and negative 6, negative 0.75. So again, there's my other curve. So had I not taken the time to figure out what my vertical asymptote is, I wouldn't know what numbers to put in as the x values for my t-tables. So remember, I'm going to pick numbers that are on either side of that vertical asymptote, because the graph does not exist there.